A hot, sticky afternoon can look harmless until the sky suddenly starts building upwards. A thunderstorm is really a tall engine in the lower atmosphere, powered by rising air, cooling water vapor, and changing winds. In Australia, that engine often starts when three ingredients meet at the same time: moisture, lift, and instability. Moisture is the raw material. It is the water vapor in the air, and a handy clue is the dew point. When the dew point is higher, the lower atmosphere usually has more moisture available for cloud and rain. But moisture alone is not enough. The air also needs a push. That push is called lift. Lift can come from strong surface heating on a hot day, a cold front forcing warm air upward, a sea breeze moving inland, a trough or air being pushed over hills and ranges. The Great Dividing Range can help by forcing air to rise, cool, and condense on the windward side. The third ingredient is instability. In simple terms, instability means a lifted bubble of air stays warmer than the air around it, so it keeps rising. As that air climbs, it expands and cools. When it cools to the condensation level, water vapor turns into tiny cloud droplets. That process releases latent heat, which gives the updraft extra energy and helps the cloud grow taller. This is how a puffy cumulus cloud can become a towering cumulonimbus cloud. Sometimes, though, storms fail to fire, even when it feels muggy. A warm layer above the ground can act like a lid, called a cap or inversion. If the cap is too strong, rising air stalls. If strong heating, a front or a sea breeze breaks the cap, storms can develop quickly. Once a thunderstorm begins, it usually moves through three stages. The first is the towering cumulus stage. Updrafts dominate, moisture is carried upward, and the cloud grows rapidly. Rain may not reach the ground yet, but the storm is gathering strength. The second is the mature stage, when the storm is usually most dangerous. Updrafts and downdrafts exist together. Rain, hail, lightning, and gusty winds are most likely now. If wind shear changes wind speed or direction with height, the updraft can tilt away from the downdraft. That separation can help a storm organize, last longer, and, in some cases, become a supercell. The final stage is dissipating. Downdrafts spread cold air near the ground and cut off the warm inflow feeding the storm. The updraft weakens, rain eases, and the cloud begins to break apart. Some thunderstorms last only about 30 minutes, while others can continue for several hours. Severe thunderstorms are the ones that pose the biggest threat. In Australia, warnings focus on hazards such as large hail, damaging winds and heavy rain that may lead to flash flooding. A microburst is one especially dangerous feature. It is a powerful downdraft that hits the ground and spreads outwards suddenly, producing very strong winds over a small area. Along the east coast, warm ocean water and humid onshore winds can add extra moisture. If that air is lifted by a sea breeze, terrain, or a trough, storms can grow more easily. Across southern Australia, cold fronts often provide the lift needed to turn warm, unstable air into lines of thunderstorms. The key is not just heat and not just humidity. Thunderstorms form when moisture, lift, and instability line up. Then updrafts keep the cloud growing. Watch for dark, rising towers, thunder, lightning, sudden wind changes, hail, or heavy rain. And when storms are active, check the latest Bureau of Meteorology warnings and local updates before you head out.